Thanks for that kind introduction, Steve. Hello everyone. As Steve said, I'm Andrew Heap. As the Chief of the Minerals, Energy and Groundwater Division at Geoscience Australia, it's my great pleasure to also welcome you to the final showcase of the Exploring for the Future program. Today, I want to expand on the comments made by Minister King and our CEO, James Johnson. My aim today is to provide an overview of the last 8 years of the Exploring for the Future program and consider the legacy of what I think has been a truly remarkable program, and definitely one of our most successful. Before I get to that, I want to begin by reflecting on the context for the program. In many ways, some key domestic and global events of 2016 are still challenges we face today, though many have grown in significance. In 2016, the cost of living challenge started to gain prominence, represented in the debate through reference to people's breakfast choices. There were concerns about the future of the Australian economy, as the September 2016 quarter reported the worst fall in GDP since the global financial crisis. Geopolitical tensions and trade reorganisation were building, signalled by Brexit and a trend towards nationalism. In April 2016, the Paris Agreement on climate change was signed. This set the path for the global transition to net zero and a surge in demand for energy transition minerals and low carbon energy. In Australia, these global events were set in the context of an unusually wet winter and spring, followed by a 3-year drought, placing a strain on Australia's precious water resources. It is with this backdrop that the genesis for the Exploring for the Future program occurred, with the aim to help address the 3 challenges just outlined by James in his talk. So let me elaborate a little more. Australia's resources sector has long been a backbone of the Australian economy. In 2016, the sector contributed to 6% of our GDP. In 2024, it accounts for 13%. The sector supports about 300,000 jobs and is responsible for 2/3 of Australia's total merchandise exports. As we look to the future, realising our net zero emission goals by 2050 presents a huge opportunity for the sector. The International Energy Agency estimates that by 2030, the world will need 41 new nickel mines, 30 new lithium mines, 11 new cobalt mines, and over 100 new hydrogen plants. And the forecasts for 2050 are even larger. Getting to net zero will rely on maintaining a pipeline of new resource projects, which relies on new discoveries based on exploration. But exploration is a very risky business, especially in new regions or for new commodities. In terms of minerals, when we started the Exploring for the Future program in mid-2016, that pipeline was at risk. Australia's share of global mineral exploration expenditure had been declining from a record high of 23% in 1993 to an all-time low of 8% in 2015. In real terms, Australia's expenditure on minerals and energy resources was the lowest it had been in a decade. Industry said that they were leaving us, as they thought the exposed geology across the surface of Australia had been explored and the search space was all but exhausted. The challenge, defined through the Uncover initiative, was to unlock the exploration frontier at depth, or the 80% or so of Australia's land mass where prospective geology is beneath layers of sediments and younger rocks. Below the surface is also where Australia's precious groundwater resources are. As the driest inhabited continent on Earth, Australia is highly reliant on groundwater for town supply and agriculture. In Australia, groundwater comprises about 30% of our national water consumption, and is the only reliable, cost-effective source of water for communities and industries across 60% of our landmass. Importantly, about 38% of mine development relies exclusively on groundwater. According to the Australian Bureau of Statistics, agriculture is the biggest user of water in Australia, with groundwater supporting 29% of irrigation. A key objective of Australia's National Water Initiative is to return all systems to environmentally sustainable levels of extraction. A 2022 study by the National Centre for Groundwater Research and Training found setting these limits is currently the greatest challenge facing groundwater managers in Australia. This challenge is exacerbated by climate change, which is placing additional stress on our groundwater resources. Given Australia has some of the largest groundwater flow systems in the world, with many hydrogeological units crossing state and territory boundaries, decisions regarding the sustainable management of the total resource need to be based on robust cross-jurisdictional information. However, when we began the Exploring for the Future program, our most recent national scale map of hydrogeological units was from 1987 and was due for significant revision and updating. In this context, the federal government invested $225 million over 8 years into the Exploring for the Future program, led by Geoscience Australia, to provide national-scale geological data and information to inform decisions by industry, government and the community on the development of Australia's mineral, energy and groundwater resources. The first 4 years were focused on Northern Australia, and then the program was expanded nationally. Our focus was primarily on geoscience data collection and analysis to enhance our understanding of Australia's geology and thereby the national resource potential. This map shows the transformational scale of our data collection and analysis. Whenever I look at this map, I'm in awe of what we've achieved. I'm also grateful for the support of our research partners, especially our state and territory counterparts and colleagues in academia, without whom this national scale data collection would not have been possible. Together, we collected hundreds of thousands of line kilometres of airborne geophysics, measured the geophysical response at thousands of stations, analysed the chemical composition of tens of thousands of rock, soil and water samples, analysed over 124 million mineral grains and drilled tens of kilometres of rock. We released over 1,000 new data sets and publications and added more than 9.6 million data points to our national data holdings. This was truly an immense undertaking, and I'm proud to say that it is the envy of the world, to the extent that other countries are now looking to emulate what we achieved. I now want to highlight these achievements in more detail under each of the 4 themes of the program. First, I want to highlight some of our stakeholder engagement and data collection activities. Our national scale data collection was underpinned by our deliberate focus on community consultation. Our data collection activities span 56% of Australia, covering more than 120,000 individual land parcels and requiring direct consultation with over 1,000 unique stakeholders. Later today, as part of the showcase, my colleague Margaret Sweeney will talk more about how we went about this and the positive effects our approach had on realising the objectives of the program. Importantly, our engagement activities did not stop at consultation with directly affected stakeholders. We also proactively engaged with the wider community by participating in community meetings and agricultural shows with our mobile laboratory to demonstrate what we were doing and why it's needed, including how our data and information might be useful for local communities. We also visited schools to give hands-on demonstrations to students about the work we do and explain how our understanding the geology can tell us so much about the world, looking to inspire a new generation of geoscientists. And, as James said in his presentation, we actively sought to deepen our engagement with First Nations groups. We were keen to build relationships and learn how earth science knowledge could be used to support First Nations people's priorities for economic and environmental self-determination. In response to their requests, we subsequently established partnerships with 3 groups: the Jungan people of North East Queensland, the Anandiliakwa Land Council on Groote Island in the Northern Territory, and the Dugalanji Aboriginal Corporation working with the Lake Eyre Basin Rangers in southwest Queensland. Through these partnerships, we co-designed projects and shared our understanding and capabilities with each other. Here is an example of the use of our radiometric data, which measures naturally occurring concentrations of potassium, thorium and uranium to map soil properties. The First Nations groups use this data in combination with their own knowledge to assess the health of their country and make informed choices about land management. You can find out more details in Meredith Orr's presentation later today. We refer to our work as pre-competitive geoscience, as our data and information is provided to everyone as a public good. It is provided publicly to help inform decision-making on the sustainable development of Australia's natural resources by all stakeholders. For industry, it also lowers the risk of resource exploration by focusing companies to the most important and prospective areas. It's important to remember that pre-competitive geoscience comes before industry investment, not instead of it. The Exploring for the Future program achieved a step change in our data management and delivery. Nearly all of our science products are now accessible through our online data discovery portal. Here you can explore and access literally hundreds of geological, geochemical and geophysical datasets, maps and decision support tools in both 2D and 3D. Later today, my colleague Mark Webster will discuss the portal and the data and information it contains in more detail. We know that the insights we gain from analysing the data we collect, compile, analyse and deliver is also useful to non-geoscientists. In response, we developed GeoInsight, a pilot online platform providing regional scale summaries of our current knowledge of minerals, energy and groundwater resources across Australia, specifically for non-geoscience experts. I'm very proud of GeoInsight. It was the first data and information delivery system to be co-designed with non-geoscientists and is being released today. I strongly encourage you to stay online to hear more from Catherine Waltenberg about this wonderful product and new direction for Geoscience Australia. The second theme I want to talk about is the progress we have made on advancing Australia's national data coverages. As I mentioned before, the Exploring for the Future program has been key to expand Australia's national geoscience data coverages. Here is a snapshot of over 40 datasets that were augmented or extended by the program, and which characterise Australia's land surface, sedimentary basins, the crust and the lithospheric mantle, from outcrop at the surface to depths of up to a few hundred kilometres. Other countries seek to emulate what we have done, but we are not resting on our laurels. Through the Exploring for the Future program, we maintained our global leadership by beginning to assemble a raft of new geochemical, geophysical and geological datasets. We targeted our data collection to meet the needs of exploration and natural resource management, but the datasets have broader applications in areas such as community safety and infrastructure planning. To unlock the uncover search space, much of our data collection focused on imaging the subsurface. We initiated the AusAEM 20 km spaced airborne electromagnetic survey, which now covers 70% of the mainland. We doubled the deep-looking AusLAMP magnetotellurics coverage, which now spans over 50% of Australia. We started one of the world's largest passive seismic surveys, simultaneously deploying stations spaced 200 kilometres apart. And we expanded our isotopic mapping program into 3 new isotopic systems. Having said that, the rise in importance of critical minerals, many of which have not previously been explored for, meant that the land surface re-emerged as an exploration frontier. We therefore reinvested in mapping surface chemistry and mineralogy to support discovery of these new critical minerals. Each of these geophysical and geochemical endeavours was complemented by continued research and development, allowing us to map the properties of the Earth with greater fidelity and certainty than ever before. I'm convinced the datasets we have been collecting will be one of the most enduring legacies of the Exploring for the Future program. The datasets will be built upon as we seek to establish national scale and higher resolution data coverage, and will be reinterpreted for many, many years. Each dataset could be the focus of a dedicated talk. However, I'll just highlight one for now. As I mentioned earlier, when we started the Exploring for the Future program, we only had the national map of surface geology, but our aim was to unlock the undercover search space. With this objective in mind, we set out to systematically map the subsurface geology across Australia using our geophysical datasets, drill holes and relevant state and territory datasets. Fast forward 8 years, and it is my great pleasure to release today the world's first layered geology map of a continent. It reveals the geology beneath sediments and rocks laid down over successive geological eras. The scale of the undertaking to produce the layered geology map for Australia cannot be understated. About 7,600 individual geological units have been mapped consistently across Australia, resulting in 185,000 polygons across 5 time periods. With our growing coverage of sediment thickness shown here, we will soon be able to know both the lateral distribution of Australia's major rock types and their depths, paving a way forward for a national 3D geological model. Please tune into Guillaume Sanchez, Sebastian Wong and Nadej Rollet's presentations on this world-first solid geology map to find out more. Combining the national datasets in innovative ways brings new possibilities. A notable step change brought about by the Exploring for the Future program has been to take the datasets and combine them to assess the resource potential for specific minerals, energy and groundwater resources across Australia. Each resource assessment we undertook as part of the Exploring for the Future program was a dedicated body of work, and together they are the beginnings of an inventory of Australia's resource potential. For explorers, resource assessments identify new prospective ground to peg or start a joint venture. For communities, They provide information of what is known about the local resources and potential development opportunities compared to elsewhere. And for government, they can inform land use planning such as the placement of conservation zones or locations for targeting industry support. The top three maps on the left of the slide show where a particular combination of geological processes occurred to maximise the chance of discovery of certain styles of nickel, copper and rare earth element deposits. This is a style of resource assessment pioneered at Geoscience Australia in 2016, and we continue to improve it by refining input data sets and applying more advanced analytical techniques. The map on the bottom left is our Atlas of Australian mine waste. Together with the state and territory geological surveys, about 80 mine waste sites across Australia are being sampled and analysed for critical minerals occurrences through a collaboration with the University of Queensland. Importantly, and in a major development of our thinking, we have gone beyond mapping geological potential. We now provide tools to identify economic fairways, which provide a first-order estimate of a potential project's economic viability. The map on the right shows the economic fairway for green hydrogen, the one below that for green steel manufacturing, and below that the relative cost of carbon capture and storage. Each assessment is underpinned by specific resource development cost models, but also the distribution of infrastructure, variations in royalty payments, and geology. The innovation and utility of this work was recognised by being awarded the Eureka Prize for Sustainability in 2023, which is like the Oscars of Australian science. The last map on this slide shows the distribution of 42 national hydrogeological units, which we have rapidly assessed to update our national hydrogeological knowledge. Now, we are progressively building our understanding of these units by combining and standardising legacy data and information. As you can see, building a unified national inventory of resource potential is quite complex. I want to highlight some of that complexity, which we address through the Exploring for the Future program. On the left of the slide are three mineral system potential maps. They map the spatial likelihood of different earth processes coalescing to form a copper ore deposit, with more favourable areas shown in red. The top map is our newest model for iron oxide copper gold style mineralisation, which my colleague Ariane Ford will speak to in detail on Thursday. You can see the map has a higher spatial resolution, as it is the first one to incorporate information from the layered geology map I referred to earlier. As we assess different mineral systems, we can start to combine them to map overall copper potential across Australia, and not just the potential of any one system. We still have quite a few systems to assess before a comprehensive picture emerges for any commodity right now, but we have made great strides in developing a robust methodology and applying it to a key commodity type under the Exploring for the Future program. To test the rigour of the national resource potential models, including constraining unknown geology, we completed several regional projects that involve more detailed study, including stratigraphic drilling. This is a map of the regional projects in the second phase of the program, which ran from 2020 to 2024. I'll highlight just two, starting with the Paderca Basin, shown in the brown, which spans the Northern Territory, South Australian Queensland border, and then moving to the Upper Darling Barker River floodplain, shown in purple. In the Paderca Basin, we wanted to know why past exploration for oil and gas had failed. To do this, we reprocessed valuable legacy seismic reflection data and analysed legacy drills. Our analysis showed that there is some potential for undiscovered oil and gas within sediments over 200 million years old. But the basin presents a much greater opportunity to store up to 15 gigatons of carbon dioxide in shallower rocks about 140 million years old. This result indicates that the region could support multiple commercial-scale carbon storage projects injecting about 50 million tonnes of carbon dioxide per annum over a 20-year period. This example shows the value in repurposing datasets to address new challenges, an approach that we will continue to implement into the future. The second example comes from the Upper Darling Barker River floodplain. Here, the town of Wilcannia in central western New South Wales has been severely impacted by recent droughts, and residents were forced to truck in potable water in 2019. Through our airborne electromagnetic data collection and application of ground-based surface magnetic resonance techniques developed in-house, we identified potential for new sources of groundwater for the town, which are shown in blue on this map. Drilling and pumping are being considered to test these findings and possibly drought-proof Wilcannia. Given the Murray-Darling Basin is one of Australia's best studied waterways, the identification of possible significant new water resources near Wilcannia highlights just how little we know about Australia's precious groundwater systems. I encourage you to listen to Sarah Buckerfield and KP Tan's presentations about this fascinating work. I hope this overview has given you a sense of the important work we have done and the amazing scientific outputs that have come out of the Exploring for the Future program. In the remaining time, I want to loop back to some of the challenges I outlined at the beginning and reflect on some of the impacts of the program thus far. Over the course of the program, we have tracked industry use of our outputs through ASX releases and by contacting companies to learn how they have used our data and information. This tracking reveals the Exploring for the Future program contributed directly to more than 70 companies to explore across almost 600 new tenements spanning approximately 490,000 square kilometres. That's an area more than double the size of Victoria. From the colours on the map, you can see that many of the explorers are targeting elements on Australia's critical minerals and strategic materials lists. The map singles out rare earth element explorers, and in his presentation before me, James Johnson highlighted the 4 rare earth element discoveries that have arisen so far from this work. Our work also supported a wave of natural hydrogen exploration, as well as the search for gas in Queensland and the Northern Territory. I think it's important to note that most of these new tenements occur in underexplored frontier regions. The Tennant Creek to Mount Isa region is a prime example of where the concurrence of new data, resource assessments, and deep dive projects has unlocked a new exploration search space. Much of the mineral exploration in the region is by junior companies, some of which have established joint ventures with majors. They are in many ways the engine room of Australia's exploration sector, historically accounting for 73% of resource discoveries. While this result is excellent in and of itself, we should compare this level of activity in a global context. Returning to the graph I showed at the beginning of my talk, I can reveal that over the life of the Exploring for the Future program, Australia's share of global exploration expenditure has risen from 8% in 2015 to 18% in 2020 and has since stabilised. From these data, at face value, it appears that over the last 8 years there has been a change in the perception by industry that there are few exploration opportunities in Australia. A recovery of exploration activity is great, but how effective is it? To answer this question, we teamed up with Minex Consulting to look at Australia's share of world-class mineral discoveries, those worth over $200 million US, as they account for the majority of value creation. Since 2017, globally there have been 41 world-class discoveries, 10 of which were in Australia. This level of performance is supported by programs like Exploring for the Future, as 7 of the 10 discoveries were supported by pre-competitive geoscience. Without this information, these discoveries would have been significantly delayed or not have happened at all. But information alone does not generate this success. Rather, it's the combination of available world-class information and its use by highly entrepreneurial and world-class Australian explorers. That's the secret to this success. The work and impacts I have shown from the Exploring for the Future program would not have been possible without the inputs of all of our research partners, shown here. And while this showcase marks the end of the Exploring for the Future program, it is not the end of our work to understand the mineral, energy and groundwater resources for Australia. The multi-decadal investment in pre-competitive geoscience through the Resourcing Australia's Prosperity initiative brings opportunities for further collaborations as we look to the future. To conclude, I've given you a glimpse of what the Exploring for the Future program has achieved over the last 8 years. I hope I've been able to highlight the material difference pre-competitive geoscience makes and has made to resource discovery and improving management of Australia's natural resources. Over the next 4 days, you'll see the immense scale of what we have achieved. We listened to your feedback where there was a desire for more talks, so this year's showcase is our largest. Exploring for the Future's legacy will continue for decades to come. The future for pre-competitive geoscience in Australia is bright. The Australian Government's landmark $3.4 billion investment over 35 years through the Resourcing Australia's Prosperity initiative allows us to continue to build on the success of the Exploring for the Future program and a future made in Australia. I hope you enjoy this year's showcase and find value in the impressive suite of new data and information that has come out of the program. Thank you for your attention today, and back to you, Steve.